All right, so now we're going to move on to graphing parabolas, and this is where I'm going to go over vertical stretch, vertical shrink, horizontal stretch, and horizontal shrink. So we start first with our vertex. And the vertex is going to be, the x-coordinate will be whatever makes that parenthesis equal to 0. So in this case, -2, and then we keep the 8. We keep the sign of the number on the right, the k. All right, and that's the y-coordinate of the vertex. So -2, 8 is the point of my vertex. Now I'm going to plug that into my chart. -2, 8. Since the number is a whole number in front of the parenthesis, we're going to go one less and one more. -3 plus 2 is -1. -1 squared is 1. 1 times -2 is -2. Plus 8 is 6. And if that's 6, this should be 6. You want to check it. -1 plus 2 is 1. 1 squared is 1. 1 times -2 is -2. Plus 8 is 6. And we're going to plot those 2 points. -3, 6 and -1, 6. And this graph is going to go down quicker than a y equals x squared type graph. All right, quicker than the parent graph. So when that number is bigger than 1 or less than -1, we have vertical stretch and we have horizontal shrink. Now, over here we have a fraction in front. So my vertex is going to be what makes the parenthesis equal to 0. 3. And then the number out here with its sign of -9 is the y-coordinate of the vertex. So I put 3, -9 in the middle. Now I want to pick numbers that are going to make my parenthesis a factor of 3. So when I multiply by 1/3, I get a whole number. So if I put 0 here and 6 here, that'll work out. 0 minus 3 is a -3. -3 squared is 9. 9 times 1/3 is 3. And 3 minus 9 is -6. 6 minus 3 is 3. 3 squared is 9. 9 times 1/3 is 3. And 3 minus 9 is a -6. So when I go to plot those 3 points, 3, -9, 0, -6, so we're at right here, and then 6, -6 right here. My parabola will now open wider. That's vertical shrink and horizontal stretch. And now as I scroll down, on the next two, same deal. My vertex here, what makes the parenthesis equal to 0? 1, and we keep that sign for the k, -10. So 1, -10 is right here. All right, I'm going to put my x, y in there, and we get 1, -10. I'm going to go 1 less than that, 0, and 1 more than that is 2. 0 minus 1 is -1, -1 squared is 1, 1 times 4 is 4, 4 minus 10, -6. 2 minus 1 is 1, 1 squared is 1, times 4 is 4, minus 10 is a -6. So we have 1, -10, now 0, -6, and 2, -6. So you can see this parabola much skinnier and goes up much quicker. Vertical stretch, horizontal shrink. As I come to the last one here, my vertex is -2, 6. -2, 1, 2, 3, 4, 5, 6. If I put that in my chart, I'm going to put the vertex in the middle. I'm going to go 2 less and 2 more. -4 and 0. Because I want to keep numbers that are divisible by 2 so I can get rid of the fraction. -4 plus 2 is -2. -2 squared is 4. 4 times -1/2 is -2. And -2 plus 6 is 4. 0 plus 2 is 2. 2 squared is 4. 4 times the -1/2 is -2. And -2 plus 6 is 4. So -4, 1, 2, 3, 4, 0, 4. And the graph opens wider. Okay? And this represents vertical shrink and a horizontal stretch. And if you notice, also, for each one where the term in front of the parentheses, that A term is negative, my parabola opens down. When the A term is positive, my parabola opens up. Now we're going to go into graphing. Okay, so now we're coming to graphing the equation of the lines. Now we're dealing with inequalities, which essentially means we're doing the same exact thing. We just need to shade. So for an equation of a line, I'm still solving for y. 3y is less than or equal to negative 4x plus 12, and then I divide everything by 3. Y is less than or equal to negative 4/3 x plus 4. So 1, 2, 3, 4. My y-intercept is 4, and my slope is negative 4/3. Up 1, 2, 3, 4, left 3. Down 1, 2, 3, 4, right 3. Since it's less than or equal to, it is a solid line. And I'm going to plug the point 0, 0 in. 4 times 0 plus 3 times 0 is less than or equal to 12. So 0 is less than or equal to 12. That is a true statement. So I shade toward the 0, 0. Try an extreme point to check it. Negative 100, 0. 4 times negative 100 is negative 400 plus 0. That's less than 12. For here, we're solving for x. So we subtract 2, or solving for y, excuse me, so we subtract 2x on both sides. When I divide by my negative 5, I've got to flip the inequality. It becomes less than now. It's a positive 2/5 x minus 3. So I go to negative 3 and positive 2/5 x, up 2 over 5, down 2, left 5. And this is a dotted line. The line is dotted because it's just a less than. Right? When I plug 0, 0 in here, 2 times 0 minus 5 times 0 is greater than 15. I get a statement that is false. So we shade away from the 0, 0. Try an extreme point. 100, 0 should make this statement true. 2 times 100 minus 5 times 0 is certainly greater than 15. So I most likely did it correct. With absolute values, okay, keep in mind the one on the left is going to open up with vertical stretch, horizontal shrink. The one on the right is going to open downward with vertical shrink, horizontal stretch. The rest of it is the same. We just have to shade when we're done. So my vertex still, what makes the absolute value equal to 0? 2. So the vertex is still going to be 2, negative 7. And I'm still going to put my chart in. That part doesn't change. 2, negative 7 puts me right here. Okay? Now, I'm going to go 1 below and 1 above. 1 minus 2 is negative 1. The absolute value of negative 1 is 1. 1 times 3 is 3. 3 minus 7 is a negative 4. 3 minus 2 is 1. Absolute value of 1 is 1. 1 times 3 is 3. 3 minus 7 is a negative 4. And now I'm going to plot these points. 1, negative 4 is right here. 3, negative 4 is right here. And we draw our little V. Once again, I'm going to try 0, 0. If I plug 0 in for x, I get 3 absolute value of negative 2 minus 7. The absolute value of negative 2 is 2. 3 times 2 is 6, and 6 minus 7 is a negative 1. So is 0 less than negative 1? It's false. So we shade on the outside. And try an extreme point once again. Negative 100, 0. Negative 100 minus 2 is negative 102. The absolute value of negative 102 is 102. 102 times 3 is 306. Minus 7 is 299. Is 0 less than 299? Yes, it is. So that's why we're shading on the outside. Second one, my vertex is just going to be negative 4, 5. I'm going to put my x and y in, and I want to get multiples of 2 on the inside so I don't deal with fractions. So I'm going to go lower, negative 6, I'm going to go higher, negative 2. Negative 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. That's where my vertex is going to be. Okay, and this should open down. Negative 6 plus 4 is negative 2. The absolute value of negative 2 is 2. 2 times negative 1/2 is negative 1 plus 5, so we get 4 there. Negative 2 plus 4 is 2. The absolute value of 2 is 2. 2 times negative 1/2 is negative 1. Negative 1 plus 5 is 4. So it's negative 2, 4, negative 6, 4. And this opens wider. I'm going to plug my 0, 0 in. 0 is greater than negative 1/2 times 0 plus 4 plus 5. 0 is greater than, well, the absolute value of 0 plus 4 is 4. 4 times negative 1/2 is negative 2 plus 5. And 0 is greater than 3. That's false. So I'm going to shade away from my 0, 0 point. Try an extreme point. 100 zeros should make this true. 100 plus 4 is 104. The absolute value of 104 is 104. 104 times negative 1/2 is negative 52 plus 5 is a negative 47. 0 is greater than negative 47. So it's true on the outside. That's where it should be shaded. Finally, for parabolas, it's the same deal. My vertex is 5, 9. Put my chart down. 5 and 9. I'm going to go one less, and I'm going to go one more. Okay? 4 minus 5 is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. And negative 2 plus 9 is 7. When I plug the 6 in, 6 minus 5 is 1. 1 times negative 2 is negative 2. Negative 2 plus 9 is 7. When I go to plot those points, 1, 2, 3, 4, 5, it's 9. All right. 6 goes to 7. And 4 goes to 7. We're going down. Okay. Now, you want to make sure when you graph this is going down pretty quick, so the 0, 0 is going to be outside of it. Let's see if 0, 0 creates a true statement. Negative 2 times 0 minus 5 squared plus 9. Negative 5 squared is 25. We get a negative 50 plus 9. So 0 is less than or equal to negative 41. I would argue that's not true. So I'm going to shade inside my parabola. Okay? Basically shading away from the 0, 0. Let's check this point right here. 1, 2, 3, 4, 5. So 5, 0 should make this true. 5 minus 5 is 0. 0 squared times negative 2 is 0, and 0 plus 9 is 9. So my x is 5. Okay. This side of the equation becomes 9. Is 0 less than 9? Yes, it is. It's a true statement. And since that point is inside the parabola, we can shade inside the parabola because 0, using 0, 0, this point out here creates a false statement. So we want to shade away from it, so we shade inside. The last one, the vertex is negative 1, negative 8. So I plot that right there. I put my little chart in. Negative 1, negative 8. 2 less than that because I want a factor of 2. We get negative 3 and we get 1. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. 4 times 3 halves is 6. And 6 minus 8, oops, jumped the gun there. And 6 minus 8 is a negative 2. 1 plus 1 is 2. 2 squared is 4. 4 times 3 halves is 6. 6 minus 8 is a negative 2. So when I go to graph this one, we have 1, negative 2, and we have negative 3, negative 2. So this graph has vertical stretch, horizontal shrink, because that A is greater than 1, even though it's a fraction. And now when I plug 0, 0 in, 0 is greater than, so I plug my 0, 0 in. The 0 plus 1, 1 squared times 3 halves minus 8 is a negative 6 1/2. It's a true statement. What's left with 0 is greater than negative 6 halves, so we shade inside. And that's our answer. And that can be checked by any point you'd like inside the parabola.